So, good afternoon, everyone. Trust we are all doing fine. Now, guys, so today we are going to start with, we are going to continue our tutorial, our online tutorial with differentiation from the first principle and the rules of differentiation. So, one of the interesting topics in mathematics is differentiation. So we'll be starting from the beginning. That is differentiation from the first principle. So whenever we have a particular function, let's say we have a function y is equals to f of x, we can derive another function from this function. So the process of we deriving a function from a particular function is known as what? Differentiation. You get that? So if y is the particular function we are dealing with, the function we are going to derive from this function y would be represented as y prime. And the general formula of we getting our y prime is actually nx raised to power n minus 1. So this y prime can be referred to as the derivative. Are you there? And the general form of a derivative when we have y with respect to x is referred to as what? dy dx, and that's equals to nx raised to power n minus 1. So someone will ask me that, what is n, what is x? Actually, this general formula is coming from the fact that, let's say we have y to ax raised to power n. So this a represents the coefficient of x. The a represents the coefficient of x. Why this n? Okay, guys. Now, so what this a represents is the coefficient of x. What this n represents is the power of what? X. So whenever we are dealing with differentiation from the first principle, we are to be using this general formula, which is what? Nax raised to power n minus 1. So let's look at some example. The first example we are going to be looking into today is example 1. If y equals x squared, find dy dx. Okay, guys, you just write solution. And you are going to note that the general formula for dy dx is anx, okay? Dy dx is anx n minus 1. So where this a would represent the coefficient of x, n would represent the power of x. So this simply means that if I want to look for my dy dx here, the formula I would be using is anx raised to power n minus 1. So my a is the coefficient of x here, which is 1. My n is the power of x here, which is 2. So this would now be equals to 1 times n, that is 2, 2x raised to power n is 2 minus 1. And this will be equals to what? 2x1, and that's equals to 2x. So this simply shows that the derivative of y is what? 2x. Do you get that? So this derivative of y can be represented as y prime or dy dx. Do you get that? Okay guys, let's look at another example. Now guys, example 2. Find the derivative of 1 over x. The question says find the derivative of 1 over x. Then what are we going to do? What I'm going to do is this. Just write solution. You just say let y equals 1 over x. You will just say let y equals 1 over x. So once y equals 1 over x, you can express this 1 over x as x raised to power minus 1. So this simply means that our y equals what? X raised to power minus 1. So once x is raised to power minus 1, then the derivative that we are looking for, which is dy dx, would be, you will just remember that the general formula for dy dx is anx raised to power n minus 1. Are you there? Where a represents the coefficient of x, n represents the power, and x is still x. So the coefficient of x here is 1. So that will be 1 times the power of x here is minus 1. Minus 1. Then x times minus 1 times x raised to power minus 1 minus 1. N is minus 1 and the minus 1 that is here. So this would be equals to 1 times minus 1 is minus 1 times x raised to power minus 2. This can be minus x raised to power minus 2. So now you have to note something. The other thing you have to note now is that from the law of indices, if you have an expression like 1 over x, you can rewrite it as x raised to power minus 1. This x will go up, while the division will change to what? Minus. While at the same time, if you have x raised to power minus 1, you can express it as 1 over x, where this negative has turned to what? Division. So also, if what we have here, let's say what we have here is 1 over x squared. You can also re-express this 1 over x squared as x raised to power minus 2. And also x raised to power minus 2 can be expressed as 1 over x squared. Do you get that? So this simply means that what we have here, we can just say this can be minus 1 times 1 over x squared. Then the final answer can be minus 1 over x squared. Okay guys, let's look at another example. Let's go for example 3. Let's go for example 3. In this example, the question is find the derivative. Find the derivative of 5 root x. Okay, guys, write solution. We say let y equals 5 root x. Are you there? So if y should be equals to 5 root x, are you there? Then this can be rewritten as 5 times root x. Then the first thing you have to note is that also from the law of indices, you have to know that root x can be rewritten as x raised to power half. Root x can be rewritten as x raised to power half. While also x raised to power half can be rewritten as what? Root x. Do you get that? The same thing is applicable to cube root x. It can be written as what? X raised to power 1 over 3. While x raised to power 1 over 3 can also be written as what? Cube root x. So that is how it goes. So this simply means that I can re-express this particular expression as what? 5 times x raised to power half. And this will be 5x raised to power half. Do you get that? So once we've understood this, then this simply means that our y is equals to 5x raised to power half. So here our a, which is the coefficient of x, is what? 5. And our n, which is the power of x, is what? Is half. So the general formula for dy dx is anx raised to power n minus 1. This is general formula for dy dx. Anx raised to power what? N minus 1. A is the coefficient of x, while n is the power of x. So this simply means my dy dx would be, our a is 5, that is 5, times our n is 1 over 2, 1 over 2, times x raised to power, our n is 1 over 2, 1 over 2 minus 1. Then this would be equals to 5 over 2 x raised to power x raised to power. Now, guys, you have 1 over 2 minus 1. If you don't know how to calculate your 1 over 2 minus 1, let me show you. Let's say you have 1 over 2 minus 1. The LCM will be 1, and this 2. 2 in 2 is 1, so that is 1 times 1. 1 minus 1 in 2 is 2. 2 times 1 is what? 2. And this is equals to what? Minus 1 over 2. So this simply means that 1 over 2 minus 1 will be what? Minus 1 over 2. Do you get that? Then you can also say that your dy dx can be equals to 5 over 2 times x raised to power minus half. Now, if your dy dx equals 5 over 2 times x raised to power minus half, then another thing you have to notice is that from the law of indices that we have been using since morning, guys, you will also notice that if you have x raised to power minus half, it can be written as 1 over x raised to power half. What is this saying is that whenever you have a particular power to be negative, either you can turn that negative to what? Division. So that is why if you have x raised to power minus half, it can be written as what? 1 over x raised to power half. While at the same time, 1 over x raised to power half can be written as x raised to power minus half. That is to say, the division has changed to what? Minus. So this simply means that I can express this as 5 over 2 times 1 over x raised to power half. Do you get that? Then this can be written as 5 over 2 times 1 over root x. Do you remember that root x can be the same as x raised to power what? Half. Now the final answer for your dy dx can be 5 over 2 root x. That's it. It's very simple, guys. So let's look at another example. Okay, guys, example 3. The example 3 is that find the derivative of y equals 4 over, find the derivative of y equals 4 over now you are looking for the derivative of y equals 4 over cube root x squared. Cube root x squared. Now listen attentively. Now the first thing you have to do is that write solution. Write solution. You know y equals 4 over cube root x squared. Now I can firstly re-express this as 4 times 1 over cube root x squared. That's the first thing I can do. Then after you've known this, let me show you another hint. This hint is that if you have x raised to power a over b, if you have x raised to power a over b, are you there? You can express this x raised to power a over b as this. B root x all raised to power a. That is to say, the denominator of the power will come inside the words roots, and then everything will now raise to the power of what? The numerator a. So this simply means that at the same time, if I have something like cube root x all raised to power a, it can be rewritten as x raised to power a over b. So the value inside the square root will be the what? The new denominator. Do you get that? So this simply means that this expression I have here, I can rewrite it as 4 times either 1 over. So using this method, either it will just be x, the power is square, the value inside the square root will not be the what? Denominator over 3. So this is the general approach. Do you get that? So once you've understood this, you will also remember that from this indices rule again, if you have 1 over x raised to power a, it can be what? X raised to power minus a. That is to say, the division can change to what? Minus. So at the same time, if we have a over b, it can also change to what? X raised to power what? A over b. So this expression that is here can also be written as 4 times x raised to power minus 2 over 3. Then this is 4x raised to power minus 2 over 3. So the first thing you have to do before you say you want to find the derivative of this y is to firstly rearrange, to firstly express your what? The question. So once you've been able to do this, then you are going to say, you will then say, if y equals 4x minus 2 over 3, either the dy dx would be a n, or let's say n ax raised to power n minus 1. Either. So you will now see that in this expression, our a is equals to 4, that is the coefficient of x. Our n is equals to minus 2 over 3, that is the power of what? X minus 2 over 3. Then if you substitute the value of this a and the n into this expression, then our dy dx would equals minus 2 over 3 times 4 times x raised to power minus 2 over 3 minus 1. That's that, guys. So the next thing you will now do is that if you use the same approach I taught you the other time, if you want to do your minus 2 over 3 minus 1, you will just say that minus 2 over 3 minus 1 over 1. The LCM is 3. 3 in 3 is 1. 1 times minus 2 minus 2 minus 1 in 3 is 3. 3 times 1, that's what? 3. And that's what? Minus 5 over 3. So this simply means that this expression here would now be minus 2 times 4. That is what? Minus 8 over 3 x raised to power minus 5 over 3. Now, guys, once you've gotten to this point, now we can also move further to our simplification as this. And this can be equals to minus 8 over 3 times x raised to power minus 5 over 3. Do you agree? Then this can further be expressed as minus 8 over 3 times 1 over x raised to power minus x is power 5 over 3. You know, we are still using the same rule, the same rule of indices that I just taught you. So that is that. So once you've done this, don't forget this x, this is a power. So then remember that you can also re-express this as minus 8 over 3 times 1 over cube root 5 all raised to power, cube root x all raised to power 5. Okay, now the final answer can then be minus 8 over 3 cube root x all raised to power 5. So whenever you are dealing with differentiation question, you have to what? Take your time. You have to calm down before you say you want to do it. No matter how simple or how simpler the question is, you have to what? You have to make sure you follow the steps in order not to get confused. So now, guys, let's look at another particular example. So in this particular example, let's simply launch into rules of differentiation. Let's simply launch into rules of differentiation. So you have to know something, that differential calculus as a topic on its own has some special formula that you have to be well acquainted with. The first rule of differentiation is referred to addition rule. The second rule of differentiation is referred to as product rule. The third rule of differentiation is referred to as quotient rule, while the last rule is referred to as chain rule. Now guys, before I will talk about these rules of differentiation, let me give you something you have to know. This thing are referred to as basic trigonometric function. Basic derivative. Basic derivative. Now the first one I'll be giving you today is that if y is a constant, the derivative of a constant number would always be 0. That is, the differentiation of any constant number would be what? 0. The differentiation of 1 would be 0. The differentiation of 2 would be 0. While the differentiation of 3 would also be what? 0. Okay? That's the first thing. The second derivative I want to give you now, number 2, is sine x. The differentiation of sine x would give us cos x. Okay? The next one you have to know is that the differentiation of cos x will give us minus sine x. The differentiation of cos x will give us minus sine x. The next thing I want to give you is that the differentiation of tan x would give us sec square x. Okay? The next thing I want to give you is that the differentiation of e raised to power x would also give us e raised to power x. And the next thing I want you to note is that whenever you see log x base e, it is the same thing as ln x. These two functions, they are what? They are representing the same thing. So it is either you refer it to as log x base e, or you refer it to as what? Ln x. So the next thing you now have to note is that the differentiation of log x base e is what? 1 over x. Let me stop here for now, guys. Now, let us talk about the rules of differentiation. Now, guys, the rules of differentiation we are going to be talking about today. The first one is we talk about addition rule. We will talk about addition rule. Now, guys, when we are talking about the addition rule, it's very simple. It's very simple. What the addition rule is talking about is that if we have a function for, let's say we have two functions either that are connected together by what? By addition. Either then if you want to look for the derivative of this, our dy dx would actually be, if you want to look for the derivative, our dy dx would actually be du dx plus dv dx. That is to say, we are to differentiate each parameter, either each parameter, we have to differentiate each parameter. For example, example 1. Let's say we have y equals 5x cubed plus 4x squared plus 3x plus 5. Find the y dx. Just write solution. Now, listen attentively. It's very simple. So, once you write solution, your dy dx equals. So, what you are going to do is that you are going to differentiate 5x cubed. You will also differentiate 4x squared. you will also differentiate 3x, and you will also differentiate what? 5. So now let me give you a hint. That is, whenever you are differentiating, are you there? You don't need to be writing the formula. What do you need to do? You have to understand two things. That whenever you want to differentiate a particular expression, if you want to differentiate a particular expression, what you have to do is that you are going to look for the power of the x in that expression. Once you've known the power of the x in that expression, you are going to be doing two things with the power. The first thing you'll be doing with the power is that you are going to use that power to multiply the coefficient of x. And the second thing is that you are to minus 1 from the power. So guys, this simply means that if I want to differentiate 5x cubed, what am I going to consider like that? I'm going to consider the what? The power. The power of x here is what? 3. So I'm going to be doing two things with the power. The first thing I will do is that I'm going to use that power to multiply the coefficients, and I will also minus 1 from the what? Power. So the power here is 3. I will use this 3 to multiply the coefficient 5. That will give me what? 15. X. After that, I'm going to minus 1 from the what? Power. So 3 minus 1 will give me what? 2. So that will be 15x squared. Plus, I will also repeat the same process for this. The power is 2, right? I'm going to use this 2 to multiply the coefficient of x, which is 4. So 2 times 4 is what? 8. X. And I would also minus 1 from that power 2. It will remain what? 1. And that is what? 8x. Because anything raised to power 1 is that thing. Plus, yeah, I want to differentiate 3x. The power of x here is 1, right? So what I'm going to do with the power 1 is that I'm going to use that 1 to multiply the coefficient of x, which is 3. So that will give me 3. Right? And it remains x, right? So I'm going to minus 1 from the power. The power of x here is 1. So if I minus 1 from it, it will remain what? 0. Then it returns to x raised to power 0. And remember that anything raised to power 0 is what? 1. So that is why this will now be what? 3 times 1. So plus, and remember, the first law I gave you is that whenever you are differentiating a constant number, whenever you are differentiating a constant number, the differentiation of a constant number will give you what? 0. So this will be what? Plus 0. So this simply means that the final derivative of this, the y dx, would be what? 15x squared plus 8x plus 3. That's how to do it, guys. So guys, before I move on to product law, let's check another example. Okay, I'm rubbing this off. Example 2. Find the derivative of y equals x squared minus 3x plus 1. X squared minus 3x plus 1 all over x squared. Now guys, you were asked to differentiate this expression y equals x squared minus 3x plus 1 all over x squared. What are you to do? Don't be scared. What you have to do is that just calm down. Are you there? Then if you check this expression, what you can do is that you can use the denominator to simplify the expression. How can you use the denominator to simplify the expression? Check this out. So you just write solution, then y can be x squared over x squared minus 3x over x squared plus 1 over x squared. Do you get that? Just use the denominator to simplify. So once you've done this, then this can equal to this one will cancel out. That will remain what? 1 minus. If you remove x from x squared, it remains x. 3 over x plus 1 over x squared. That's it, guys. So once you've done this, it remains one thing you are going to do before you say you want to differentiate. What's that one thing? Is this. You will just try to bring this x up. Bring this x up, bring this x squared up. Don't forget that whenever, if x should go up, either this division will just what? Negative. So therefore, our y would then be 1 minus 3x minus 1 plus x raised to power minus 2. Are you there, guys? So once you are at this point, we can then go to for our what? The y dx. Now, guys, look at this. Do not forget, I give you a scope on how to differentiate without using the formula. What you just have to do is that whenever you want to differentiate a particular expression, you have to check the power of that expression. If the power of the once you know the power of the expression, you will just use. You are going to do two things with the power. The first thing is that you are going to use that power to multiply the coefficient. While the second thing is that you are going to subtract 1 from the what? Power. Everybody, don't forget, the differentiation of a constant number is what? 0. So this simply means that the differentiation of 1 would give me what? 0. Minus. Now, I want to differentiate 3x raised to minus 1, right? So the power of x here is what? Minus 1. Firstly, I will use that minus 1 to multiply the coefficient of x. Secondly, I'm going to minus 1 from the what? From the power. So if I use this minus 1 to multiply the coefficient, I'll just open brackets. Minus 1 times 3 x raised to power. Then I'm going to minus 1 from this power. How would that be? Minus 1 minus 1. Plus. Do you get that? The next thing, the same thing I did for this, is what I'm going to do for this also. I'm going to use the power to multiply the coefficients, and I am also going to minus 1 from that power. Then this would also be minus 2 times x minus 2 minus 1. You can see it's very simple, right? So once you've done this, then you're going to say something that this expression would change to now. But look at something. There is minus here, there is minus here. Hey, but what is minus times minus? Plus. Okay, this is minus 1, minus 1. Everybody, what is minus 1 minus 1? Minus 2. So this would now be, this expression would change to 3x squared plus. Now, yeah, am I going to put plus or minus? Let's check this out. What is here? Plus. What is here? Minus. Hey, but what is plus times minus? Minus. So here should be what? Minus. Okay, guys, what is minus 2 minus 2? That is minus 3. And here we now be what? Minus 2x raised to power minus 3. Now, finally, I can then get my answer. Note here should be minus 2. Then I can get my answer. If you just see that the y dx equals 3x minus 2 minus 2x minus 3. Right? Okay. Don't forget that this my x raised to power minus 2. I can turn this negative, I can bring it, I can turn this to division. And once I'm turning this negative to division, then this x would become the what? Denominator. So this will now be expressed as 3 over x squared minus 2 over x cubed. This is the final answer. Okay guys, let's now move on to product rule. Product rule. Guys, we are to use product rule when we have functions that are connected together by multiplication. So guys, what is product rule? We have to use product rule when we have the expression of something like this, uv. That is, we have a particular function connecting to another particular function by what? Products. So what am I to do? I am to use what? Product rule. Now, what is a product rule? Oh, what is a product rule? The product rule is very simple. The product rule is that the y dx equals the y dx equals v du Now, guys, look at this. The formula for the y dx is what? V du dx plus u dv dx. In some particular textbook, you might see this as u dv dx plus v du dx. Now, you see, the arrangement does not matter, although it matters a little. The reason why the arrangement does not matter is because what is here is what? Is addition. There is not much problem with addition, because when you have the expression 3 plus 2, the expression 3 plus 2 will give you what? 5. And if you also have the expression 2 plus 5, the expression 2 plus 5 will also give you what? 5. Do you get that? Okay, if you get that, that's correct. So let us now look at a particular example. Example 1. Find the derivative of 3x squared plus 4 times 1 plus 1 over x. Okay guys, you will now see that in this particular expression, we have two functions in which they are connected together by what? Multiplication. You can see that this is a particular function connected to this particular function by multiplication. Then what are we to do? This is what you have to do. So the first function, you are going to represent it. The first function, you are going to represent it as u. While the second function, you are going to represent it as v. Do you get that? So you just say solution. Let u equals 3x squared plus 4. Instantly, look for du dx. And if you're looking for du dx, you are going to differentiate this, also differentiate it. You have already known that the differentiation of a constant number is what? 0. So the differentiation of 4 is 0. While the differentiation of 3x squared, that will just be 2 times 3, that is 6. 2 minus 1, that is 1. Then this will give us what? 6x. Also, you also say, let v equals 1 plus 1 over x, which can be rewritten as 1 plus x raised to power minus 1. So you're going to say let v to be equals 1 plus 1 over x, and this 1 over x can be written as what? X raised to power minus 1. Do you get that? So the differentiation of 1 would also give us 0. Why the differentiation of x raised to power minus 1? Differentiation of x raised to power minus 1. You are going to use the minus 1 to multiply the coefficients. So that will be minus 1x, and you also minus 1 from the power, that will be what? Minus 2. Because minus 1 will give us what? Minus 2. Guys, so this simply means I'm going to look for the v dx. The v dx, and this will now be, this one will be 0, right? And this one will now be minus x raised to power minus 2. Because you are going to use this minus 1 to multiply the coefficient, and you also minus 1 from the minus 1 that is there. So minus 1 will give us what? Minus 2. So this can then be expressed as minus 1 over x squared. Do you get that? So because you know this is x squared minus 1, this x squared minus 1, sorry, this x squared minus 2 can come to be the denominator. This minus that is at the power will toast to what? Division. And this expression will change to minus 1 over x squared. Do you get that? So once you've gotten this, the next thing you will do is that you just remember your what? Product rule. Let me tell you something. The product rule is not something that is hard. It's not hard. All what you just have to note is that, okay, in product rule, the parameters that are present in the product rule are, the first one is u, the next one is v, the next one is du dx, while the last one is what? dv dx. Okay, which one are you going to represent as u? Which one are you going to represent as v? The one you are going to represent as u would be the first function that comes. Either the first function that comes in the expression you are expressing would be your what? U. While the second function would be your what? V. Do you get that? So once you've known that, you will now remember that, okay, if I am to write my product rule, either I'm going to be taking into consideration addition. Product rule takes into consideration what? Addition. So this simply means that the formula will now be u. Either after u would be what? dv. U dv dx plus v du dx. Either. So let me tell you something. You can say u dv dx plus v du dx. Or you say v du dx plus u dv dx. Do you get that? So u goes with dv dx, while v goes with what? du dx. Irrespective of the one you are bringing first, what should connect the two together must be what? Addition. Do you get that? So this simply means that I will just say product rule is equals to u dv dx plus v du dx. So my u is 3x squared plus 4. That is to say, the first function that comes in the question. So that is 3x squared plus 4 multiplied by dv dx. My dv dx is minus 1 over x squared. Minus 1 over x squared. Plus v. V is the next function that comes. That is 1 plus 1 over x. Multiply by du dx. My du dx is what? 6x. That's it, guys. Are you there? Then the final step for the dy dx would then be, we are going to use this to open the brackets. Are you there? So minus 1 over x squared times 3x squared. Minus 1 over x squared times 3x squared. What will that give us? That will give us minus 3. Minus 3. Someone will ask me that, how is it minus 3? How is this minus 3? It will be minus 3 because 3x squared times minus 1 over x squared. This x squared, we cancel x squared. What will this remain? It will remain 3 times minus 1. Do you get that? So guys, this simply means that if I should multiply 3x squared by minus 1 over x squared, it will give us what? Minus 3. The next one is that minus 1 over x squared times 4. That will now give me minus 4 over x squared. Are we there? Yes, we are there. So what is there is plus. Then we are going to use this 6x to multiply this. 6x times 1. What will give us? 6x. Plus 6x. Plus, what is 6x times 1 over x? X we cancel x. Then it will be what? Plus 6. And the final answer would then be minus 3 plus 6. What is minus 3 plus 6? Minus 3 plus 6. What's that? That is plus 3. And that's what? 3 minus 4 over x squared plus 6x. This is the final answer. Okay? Before we move on, let's look at another particular example. If y equals x cubed dot cos x, if y equals x cubed dot cos x, find y prime. Guys, look at this example. Now guys, look at this example. Find y prime. I have told you that whenever you see something prime, whenever you ask to look for something prime, what they're asking you to look for is what? The derivative. So you have to simply use your word dy dx. You just write solution. Check this question very well. We have two functions. The first one is x cubed, while the second one is what? Cos x. So these two functions, they are connected together by what? Multiplication. And whenever two functions are connected together by multiplication, and you were asked to calculate the derivative, to find the derivative, you are simply to use product rule. Let's get this one. So we just say let u equals x cubed. Once you let u equals x cubed, instantly look for your what? Du dx. What is your du dx? That is what? 3x squared. You get that? You will also say let v equals cos x. Instantly look for your what? Dv dx. Note, the differentiation of cos x is what? Minus sin x. We're going to say that from the beginning of this question, I explained some things to you where I said the differentiation of a constant is 0, the differentiation of sin x is cos x, the differentiation of cos x is minus sin x, the differentiation of tan x is sec square x, the differentiation of e raised to power x is e raised to power x, while the differentiation of log x base e is also what? 1 over x. Do you get that? So this simply means that the dv dx when v equals cos x would be what? Minus sin x. So the dv dx here is what? Minus sin x. So guys, once you've gotten all these parameters, you are you are expected to get, then you will remember your product rule. What is your product rule? You don't need to count the product rule. All you have to note is that, okay, for my product rule, the following must be in the formula: u, v, du dx, dv dx, and you will always note that u goes with dv dx, while v goes with du dx. You will then join them together. That will then be my dy dx would equals u dv dx plus v du dx. Guys, my u is x cubed. Why my dv dx is minus sine x plus v is cos x. Why my du dx is 3x squared. Then guys, I'm going to connect these two things together. I'm going to connect them together. Let me tell you something, guys. What you have to notice is that if you have an expression like x times x, we all know that x times x is what? X squared, right? That is x squared. But if you have something like x times sine x, your x times sine x will never be sine x squared. That's wrong. Your x times sine x would equals to x sine x. Do you get that? Take note of that very well. So therefore, guys, this simply means that my dy dx would equals to minus x cubed sine x plus 3x squared cos x. Or you write it as 3x squared cos x minus x cubed sine x. Okay, that's about that, guys. Now, from here, we are going to moving on to quotient rule. We are moving on to quotient rule. Now, quotient rule will be talking